Hey class, Mr. Moyden here with a help video regarding the law of sines and cosines. Here the question asks to find the measure of angle t to the nearest degree. So right away you'll recognize that this might be a challenging problem because we're looking for an angle measurement and that might require some inverse trigonometry. Moreover, when you look at angle t, in order to figure out if this is a law of sines or cosines problem, you don't have angle t naturally. You do have the opposite side length, so that's nice. But that's not really a complete pair, which is what we look for the law of sines. We have the side of 25, we don't have angle E. We have 34 degrees, but we don't have side length little r, which is a cross trapeze. Since we don't have this pair, this is a clue that this is a law of cosines problem. The law of cosines allows us to find a side or an angle, depending on what we use it for. And the best way to go about it is to call the given angle, or the angle you're going to use, which in this case has to be 34, we're going to rename that to be big C. In which case the missing side should be little c, which is also useful because of the way we can write the formula. It's solved for little c. The other two are going to be reframed as a and b, keeping in mind that of course we're ultimately looking for what used to be called t but is now angle b. So labeling our side lengths as appropriate, this would be little a for 25 and the 20 would be lowercase b. So the law of cosine states the following. It is something you want to have memorized for an assessment. C squared is equal to b squared plus a squared. That much looks very much like the Pythagorean theorem, simply in reverse from the normal order. Minus 2 times a times b times the cosine of angle C, where C is the reference angle in a sense, or it's the only angle measurement we're given, or perhaps in some problems the angle measurement we're looking for. Although in this case it's going to be the angle we're given. So plugging everything in appropriately, keeping in mind that we don't have side length little c, sort of by design, c squared is equal to, let's see, b is 20, a is 25, plugging them in, times the cosine of our angle of 34. Now we don't have a side-by-side calculator here on this iPad, so all I'm going to do is I'm just going to use a physical calculator, but all I'm doing is I'm literally typing in all of that right-hand side that I've underlined here. I'm typing all that in one step in the calculator. It's not really too hard. You want to keep track of your parentheses if you use those for multiplication, but for the most part, it's pretty much plug and chug, as some like to say, times cosine of 34. So I have c squared to be approximately 195.96 and some more. Keep in mind that's c squared. There's no way this is 195. It just doesn't make physical sense with 20 and 25. So that of course is c squared. C would be the square root of this result. And if I take the square root of that result, I have essentially 14. 196 its squared is exactly 14, but this is really close to 14. It's 13.99865, so for our purposes we're safe to call it a fine length of 14. We still haven't found the measure of angle t, keep in mind. So reframing our discussion and summarizing, our goal is to find angle t. We don't have any method of using the law of sines because we don't have that pair, so we had to use the law of cosines, and we use that to find our remaining side length of c, which we now have as 14. So looking at the problem again, we now recognize that we can now use the law of sines. Earlier we couldn't, but now we can, because we now have this pair of side and angle. The 14 and the 34 have essentially been completed in a sense, right? They sort of fit together in the law of sines. So I'm going to give myself some room here. So I now have this pair of angle 34 degrees and opposite side length of 34. So this is a clue that I can now use the law of sines. Ultimately, I'm looking for what I've called angle T, or has now been reframed to be angle B. So I need to pair up the green sort of pair of side and angle. I need to make that in tandem with this red portion. Angle B, which is unknown, and the side length opposite it of little b, or 20. So trying to stick to the colors here. The law of sines says that the sine of an angle of a triangle divided by its opposite side length, which I have here in the green pair, is going to be constant for any pair of sides and angles in that triangle. So in this case, sine of our unknown angle b over its opposite of 20. So these are going to be constant by the law of sines. If you cross multiply these, we're going to get 20 sine of 34 is equal to 14 times sine of b. Ultimately, I'm looking for b. Right now, b is wrapped up because it has the sine keeping it sort of in its grasp, and then you also have this 14 on the outside. So I'm going to work on from the outside toward the inside, so work my way in. Divide both sides by 14. That'll give me just sine of b on the right-hand side. Now, all of this can be found in the calculator. So in one step in the calculator, I'm going to type in 20 sine 34 and get a number just sort of on pause. It's about 11.18, but I'm immediately going to divide that by 14, the exact results, and I get 0.799 approximately. 0.799. That's the value of angle B's sine. So to find the value of B proper, just B itself, all I've got to do is invert this equation. So I'm going to put angle B where the ratio was, I'm going to put the ratio where the angle was, and when I switch around my input and output, I have to give an inverse function for that to occur. So everything has inverted from the last orange step there. So this is something I can also type in the calculator, keeping in mind I can use the exact value because it's still waiting. Inverse sine of that previous answer will give me a measurement for angle B of 53 degrees. So angle B is 53 degrees. This is not drawn to scale, so you might be able to tell. Now keeping in mind that's angle B, of course originally it was known as angle T, so there's our answer, the measure of angle T. If we wanted to, just for the sake of completion, solve the entire triangle, find the remaining angle measure, that would be this pair. You could do the law of sines again if you wanted to, if you need some practice or if you enjoyed it. However, all triangles contain 180 degrees, so you can simply subtract 34 and 53 from the 180 that we have, and you get a remaining angle measurement of 93 degrees. However, the answer to the posed question, which is find the measure of angle T, that would be 53. Hope this helps.